Hello everyone. As part of learning generative AI, we shall see what are various types of generative AI models. I will list out some of the generative AI models here. So these are the artificial intelligence models which are trying to create new content. We know what type of content they are able to create. They are able to create text, audio, video, whatever messages you want, they are trying to do that. And they are trying to learn the patterns from the training data, and they are generating the outputs which are similar to the data what they have learnt. What are the major types of generative AI models? See the first one, GAN, Generative Adversarial Network. So, what type of GANs are we talking about? This contains two types of neural networks, which are known as discriminator and a generator. And generator creates the new data, discriminator tries to identify whether it is a real data or fake data. We will see in detail about GANs in the next slides. Second type of generative AI model, variational autoencoders. What do you mean by variational autoencoders? These are like they try to encode the data into a compressed latent space, and from the compressed data space they will try to generate the new data from that. So you are trying to see various applications of variational autoencoders in the later parts of the sessions. Then transformers, we are extensively working with ChatGPT. One of the examples for transformer, what exactly is the transformer doing? It works on self-attention mechanism, and what it will do is they generate contextually relevant data, contextually coherent data. So they are going to generate contextually and coherent wise, also matching data according to the context, and they are widely used in the field of natural language processing. Coming to diffusion models, what they are trying to do, the diffusion models, is they try to introduce a bit of noise into the given data, and from that they try to do the reverse of that, try to remove noise and generate the original data. So they are trying to introduce noise, and they are also learning to remove noise from the existing noised data. So we will talk about diffusion models. Then coming to recurrent neural networks and long short-term memory networks. What do we mean by these things? They are trying to help us to work with the sequence generation, and whenever you are trying to work with the time series data, I can give a best example. Whenever you are trying to work with subtitle generation, maybe a continuous audio generation, you are trying to generate a data which has to come in a proper sequence. In such cases, we are using these type of generative AI models. So various models are there, they are performing a specific task. Which one I should use obviously depends on the type of task you are dealing with. Now let us see in detail about GAN, Generative Adversarial Network. What it will be doing is, it is trying to create new data samples which are trying to match the training data. Now, whenever we are working with GANs, these are introduced by Goodfellow in 2014, and they consist of two types of neural networks, as I mentioned in the introduction. One is a generator, the other one is a discriminator. They both work in a competition like. So we exactly don't say competition, but they work as if they are in a competition. That is the reason we call it as adversarial. They both behave as if they are competitors. Let us see what that competition is all about. Generator, what the generator is doing, as the name suggests, it will try to create new or synthetic data. Say for example, it is trying to create images which is similar to the original data, right? Now what the discriminator is doing, as the name suggests, it is trying to discriminate, differentiate, and it will try to evaluate the data which is generated. It will compare it with the original data, and it will try to classify it as whether it is a real data, the newly generated one is real data or fake data. So they both will be working in a competition like, so we are calling it as generative adversarial networks. What is the goal of the generator? Because I am generating, if I am the generator, I am generating new synthetic data which resembles the real data. The purpose of the generator is to create data which is so close to the real data that nobody can distinguish it easily that this is a generated one, right? So the generator always strives to create data which is very close to the real data. What is the major purpose of the discriminator? It always tries to find out whatever the generator has generated is fake data, right? What is the major architecture of GAN? It consists of two components, as I kept on mentioning. One is a generator network, the other one will be discriminator network, right? So let us quickly look at what exactly is generator network. It consists of input, layers and output. So what the generator network is doing, it is trying to take a random noise vector and it will try to sample it. It uses various sampling techniques in order to take the random noise vector, and it will use it as its input. Now what the layers are doing, the noise vector which we have taken in the input is passed through various levels of layers, which we also call them as the convolutional layers, and you apply it to an activation function. We can select the activation function depending on our requirement. Most of the time we work with ReLU, TANH and so on. These network layers try to transform the noise into a sample which resembles the original data. See, the major purpose here is I want to create an image which exactly resembles a person, an object, which exactly resembles there. You are unable to distinguish whether I have generated that, a fake image, or is it originally existing there, right? So the generator always strives to create realistic images. So it took a random noise vector, subjected it to so many layers, and the output from these layers will be a sample which resembles the real data. What is the output? The output which is coming from the generator network is exactly or almost similar to the original data which is existing, and which is like a 2D image, audio or text. See, some people say this is not my voice, somebody has spoke or somebody has mimicked my voice. So you are trying to create an audio message or a video message which is exactly resembling the original person or original content. Now after the generator has generated, who comes into picture? The discriminator network comes into picture. Again, it also has got input, layers, output. What is the input to the discriminator network? It will try to take either the real world data which is already existing or the output from the generator network, either of them. It will try to see whichever is fake, whichever is real. So it can take either of them as the input, and it also consists of convolutional layers. It will subject whatever input it has taken to those layers and activation function, and it will try to identify whether the taken input is real or fake. The output will be a binary score or probability score. It will be between 0 to 1. If I exactly want to say yes or no, the values will be 0, 1. Sometimes you want to give the probabilistic score, like it is 10% real, 90% fake, or it is between these two. If you want to specify the range of probability, we go for a range of values between 0 to 1. If I just want to give my output as yes or no, real or fake, I go for 0 and 1, two values, right? And if you are trying to work with a range of 0 and 1, if it is very much real, it is close to 1. If it is fake, it will be close to 0 if you are working with range of values. Then what is the training process? We know we take the model, we train the model. So what is the training process that is involved in this? The generator creates a batch of fake data from the random noise. So it will create, it took the random noise as the input and it is trying to generate some batch of fake data. What the discriminator is trying to do? The discriminator is given a batch of real data as well as a batch of fake data, and it has to learn to differentiate between the real data and the fake data. How does it do? It uses some weight functions, and accordingly it keeps on adjusting the weights, and it will try to learn who are the real images or who are the real data values and who are the fake data values. Then the generator updates its weights to improve its ability to create data with which it can fool the discriminator. So after, say for example, the discriminator told whatever data you have generated is close to fake, what the generator will do is it will adjust its weight functions and it will try to adjust the weights to the input values, and again it will try to generate data wherein it will always try to fool the discriminator, right? Again, after it again generates the data, what the discriminator will do, it will try to identify whether it is real or fake. These steps are iteratively repeated until the discriminator fails to distinguish between the real data and the fake data. Loss function, whenever you are trying to work with loss functions here, how best the generator is trying to generate the data, wherein you are trying to reduce the difference between real data and the generated data. So the generator always tries to minimize the loss value. It is trying to reduce the difference between real data and the generated data. So you are trying to work with loss functions, and the generator loss is based on how well it has fooled the discriminator, and the discriminator loss depends on how well it could classify real data with fake data. So this is how you can try to explain the functionality of the generator and the discriminator. You have taken some data and given to discriminator, real data is given to discriminator. Similarly, random noise vector is taken by the generator, it has generated some fake data, that is also given to the discriminator. What the discriminator will do, it will try to identify and gives it input to generator. What the generator is doing, it is adjusting its weights and again generates fake. Likewise, these steps are iteratively repeated. Finally, the discriminator has to tell whether it is real or fake. Most of the time, the discriminator fails to recognize in the end. After all the possible iterations, you generate the data so close to the real one that the discriminator sometimes fails to recognize which one is real, which one is fake. That is the motto of generator. Then, what are the key components of GAN? As we understood, the key components of generative adversarial networks are two main networks. Each one has its own roles to play there. Coming to the generator, what is the role the generator is trying to do? We understood generator is trying to generate the synthetic data, and it is always trying to mimic the real data, right? So it is trying to generate the data which is resembling the original data, and it is using the random noise vector from the training data set, right? And what else it is trying to do? it is trying to map random noise into meaningful outputs. So, it is always trying to generate fake images from the existing data. And what is the input to the generator? We understood it is a random noise vector. Then what is the output? The synthetic data which is generated. What architecture does it follow? It uses some of the activation functions and some CNN layers. Then what is the role of a discriminator? The job of the discriminator is to distinguish between real data and the fake data. It also takes input as original data as well as the data which is generated from the generator, and output will be within the range 0 to 1 if you are trying to give a probabilistic answer, either 0 or 1 if you are just saying whether it is real or fake. Architecture, it also has some CNN layers and it also uses some activation functions in order to do the jobs, and it uses some weights in order to adjust so that it can identify what is the real data, what is the fake data. Then latent space. What is latent space? It represents from where the generator is taking the input. I told the generator is taking some random noise vector, from which space are we taking the input data. This consists of random noise vector which uses some distribution functions like Gaussian distribution and all, and from the noise vector it is trying to generate a real image, real kind of image. Loss function, what is the role of the loss function? You are trying to identify the difference between original image and the generated image. Discriminator loss, it measures how well the discriminator is able to distinguish between original data and the synthetic data. Generator loss, how well I could fool the discriminator. Based on that we are measuring the generator loss. Optimization algorithm, we try to work with an optimization function which will try to help me adjust the weights to the input data so that the generator can generate more realistic data. Then adversarial training process, this is the actual competition between the discriminator and the generator, and we try to build the adversarial functions when we are trying to build the models with GAN. Thank you.